This digital servo is a HD Power 9110 Metal Gear servo. So we're going to take a look at it. And immediately you can see that the digital servo is quite a bit different than the analog servo was. There are similarities though. And this is a Metal Gear servo. It also is a bearing servo. This is a bearing up on the top part of the output shaft. And then we have these two metal gears. I'm going to start disassembling this. Alright, the output gear also has another bearing in the bottom. There's also inside here a little plastic indicator that goes right on top of this shaft. And this shaft is the same as it was for an analog servo. It's a potentiometer that indicates the position of the head. There's a potentiometer right here that is giving the feedback to the microprocessor of where is this head located. This output gear also has a stop, and the stop works against these two post positions inside the head. There's a post here and a post here. This limits the rotation of the output gear. It has two additional screws in it, right here and right here. These are actually holding the motor up against the top of the case. So this holds this motor up here, and it prevents the movement in the motor. The analog servo, this was a S3003, doesn't have that capability. Inside this one, it simply goes up inside the case and is pressed up in there by the board being bolted into the case itself. So as this goes down into the case, then the board presses against the motor, which presses the drive gear up into the top of the housing at this point. The white stuff you see is silicone grease. What I'm showing you is a side-by-side comparison of an analog versus a digital servo. This is the analog servo, this is the digital servo. Each one of these have a motor on them. The output gear is shown here and here. This is the potentiometer that moves with the output arm and the output gear. So this is what gives feedback that tells it where the output arm is, and then that is interpreted to in turn change position of the arm by turning the motor either left or right. The analog servo has two IC devices in here. There's a smaller one and then there's a larger one. The small one is controlling the motor itself. It allows it to change the polarity on the motor and reverse the motor, or make the motor go forward, and also control the speed of the motor. The second chip looks at the position of the potentiometer and the incoming signal on the white wire. It compares those two and decides whether the position of the output arm is currently where it needs to be, or does it need to be moved. If it determines it needs to be moved, then it sends a signal over to the motor controller and changes the position of the arm by changing this until the two match. So as we indicated before, as the arm moves, this indicator right here, this potentiometer, is turned with the output arm, and it actually changes this potentiometer. The digital servo is very similar in terms of it has a motor with a geared output shaft. It also has a potentiometer. This is connected through the output gear to the arm and determines and gives feedback as to where is the arm at any given time. As this turns, the input from this potentiometer is read by the digital circuitry, and the input signal is also read. And if there's a difference between this position and this signal, then that gives a signal to move this motor, either left or right, and how fast it needs to move. If we turn the digital circuit just a little bit, we'll see that the circuitry in the digital servo is much more complicated. We have an IC here. We also have another one down here. This one's going to be the motor controller. It's controlling how this motor turns, which direction, how fast, and so forth. There's other devices on here, but this is the controller chip that is making the decisions about what's going on between the input signal and the position, and then feeding that information over to get the motor to turn. Something I'll also mention is this chip on that side of the board and this chip on this side of the board, we don't know what the part numbers are for those devices. It's fairly common for manufacturers when they want to obscure different parts of their design to keep it from being copied, is they'll grind off the component information. So the manufacturer's mark of who made this and what device it is has been ground off of the top of the chip on both of those. I'm going to reassemble this servo. One of the things that you'll want to do is make sure that the servo area where the gears and things like that are all clean. I've already inserted the motor and electronics components back into the servo body, and I've tightened the two screws that hold the motor up firm against the top of the case. And like I said, in the Futaba servo, this wasn't there, so it's a good feature that keeps it up there. Okay, I'm going to start reassembling this. I'm going to put in the output gear at the bottom. This gear actually meshes with the output drive gear from the motor. And once I get that in, I can install the alignment pin or the pivot pin. There's a long one and a short one on this particular servo. The longer one is going to go into the bottom because it has to reach all the way up. The shorter one is going to go into this hole for the other gear. And as I reassemble, I like to apply a little bit of silicone grease. Not a lot of it, but we do want to make sure that there's enough lubricant in the servo. Okay, the gears have been seated. The stop is in this position right now, and we have everything lined up and meshed. We're going to add just a little bit more lubricant. That's for the output gear, and then we're going to put a little bit on this drive gear. Okay, you don't want to get carried away on lubricant, because too much is worse than not enough in some cases. Next, I'm going to put the top on. It should go down nice and smooth. And before I put everything back together, I'm going to test it. Alright, I'm ready to test the servo before I put the bottom of the case back on and get it all sealed up. I want to do this in case there's something wrong. I can fix it before I go ahead and assemble it. I've put an arm on the top of it just so we can see the movement of the output shaft. So I'm going to go ahead and have it go to one side. I'm going to hold the cap down just to make sure it doesn't come off. Okay, so there we are at one extreme, back to center, and the other extreme.